Problems involving quadratic function. Example number 1. What are the dimensions of the largest rectangular field that can be enclosed with 60 meters of wire? So to solve this problem, first we have to identify the representation. So in here, let W be the width of the rectangular field. So to represent the length, we're going to use the perimeter is equal to 2L plus 2W because yung 60 meters of wire representing the perimeter because it enclosed the rectangular field. So perimeter is 60 equals 2L plus 2W. Since all the terms are divisible by 2, so let us divide the equation by 2. So we will have 30 is equal to L plus W. And since we want to compute a representation for L, so in here, L will be equal to 30 minus W. So that will be the representation to be used for the length. Next is for the quadratic equation or function rather, since nabanggit po yung area, the area of a rectangle is equal to length times the width. So we can say that the area as a function of W is equal to the length is 30 minus W times the width, which is W. So I wrote here A area as a function of W because our representation for the width and the length is using the variable W. Okay, so in here, let us arrange the quadratic function in general form. A of W is equal to, using distributive property, W times negative W is negative W squared, and W times 30 is positive 30W. So I change or rewrite the quadratic function in general form. Y equals ax squared plus bx plus c. So after that, getting the quadratic function, let us now solve what is asked in the problem. What are the dimensions of the largest rectangular field? So let us make this quadratic function from general form to standard form. So A of W is equal to, I'm going to factor out the negative sign and then inside the parentheses W squared minus 30W. So using completing the square method, yung 30 i-divide by 2, so that is 15, and 15 squared is 225. And then I will going to subtract 225 times A, which is what? Negative 1, so negative 225 outside the parentheses. So minus negative 225. So A of W is equal to negative times the quantity of W minus 225. So square root niyan ay 15. So this is the equivalent square of binomial of this PSTW squared minus 30W plus 225. And then yung outside the parentheses, minus negative 225 became plus 225. Okay, so how are we going to interpret this standard form in relation to the question? In the previous discussion about the vertex of the parabola, we can say that the vertex is a maximum or minimum point. So in here, if we're going to get the vertex is at 15, 225, and since the value of A is negative, so the vertex is a maximum point. And if the vertex is maximum point, the value of K here is the maximum value. Okay, so what is this 225, which is the maximum value? That is referring to the area. Okay, so that means 225 is the largest area that can be formed using 60 meters of wire. And the question is, what are the dimensions of the largest rectangular field? So, 225 is the largest area. And what is the dimension? Yung 15 na value ng h, that will be the dimension. So, that will be the value of W, which is the width. Okay? So, that means if the width is equal to 15, therefore, the length is equal to 30 minus 15. So, that is equal to 15 also. Okay? Now, to answer the question, what are the dimensions of the largest rectangular field? The dimensions are 15 meters and 15 meters. So, magkatulad lang yung length and width. Since magkatulad yung length and width, we can say that the largest rectangular field that can be formed is a square. Okay, so that's it for this example number 1. Example 2, Marlon wants to fence rectangular area that has one side bordered by an irrigation. If he has 80 meters of fencing materials, what are the dimensions and the maximum area he can enclose? So in here, if we're going to sketch the rectangular area or field, one side is bordered by an irrigation. So only 3 sides of the rectangular field needs to have fencing. Now, for the representation, let W be the width of the rectangular field, and let us use the perimeter is equal to L plus 2W. Why only L, not 2L? Because yung isang length is bordered by an irrigation. So, only one length ang lalagyan ng fencing. Plus yung dalawang widths sa gilid. Okay, so the fencing materials, the total is 80, is equal to L plus 2W. So we want L, representation for L. So by addition property of equality, 80 minus 2W is equal to L. So that will be the representation for the length. And for the quadratic function, we're going to use again area is equal to length times the width. So area in terms of W is equal to 80 minus 2W times the width. And arranging this in general form, A of W is equal to W times negative 2W is negative 2W squared. W times 80 is positive 80W. So this is the general form. Now, let us arrange this in standard form. A of W is equal to factor out A, so negative 2, times the quantity of W squared minus 40W, because we already factored out 2. So 80W divided by negative 2 is negative 40W. And using completing the square method, 40 divided by 2 is 20. 20 squared is 400. Plus 400. And then, outside the parentheses, this 400 multiplied by negative 2, so that is negative 800. So, minus negative 800. A of W is equal to, arranging the PST into square of binomial, so negative 2 times the quantity of W minus 20 is squared, and then minus negative 800 is plus 800. Now, going back to the vertex, so the vertex is at 2800, and this vertex is a maximum point. And then, according to the problem, what are the dimensions and the maximum area he can enclose? the value of K, which is 800, is the maximum value. So this is the maximum area. And the value, which is 20, is the dimension referring to the width of this maximum area. So width. So the width to be used is 20. So for the length, that is equal to 80 minus 2W. So 80 minus 2 times 20. So that is 40. 80 minus 40 is 40. Okay, so therefore, our final answer will be the maximum area is 800 square meters with dimensions of 20 meters by 40 meters. So that's it for example number 2.